Hey guys, so this is your first set of practice problems and I hope you watched my YouTube short that shows you how to solve any AP Physics 1 problem. So the first step is to draw out the problem, label your variables, then state your reference, then write down the equation to solve for all the unknown variables using your knowns, and then to plug in and solve. So with that being said, let's let's do it for all of these questions. So these are level 1 questions out of the Giancoli textbook, so go check that out if you want extra practice. And uh, in a couple of videos, there will be a quiz coming up, so make sure you're constantly studying so you make sure that you're keeping on track. So take a minute to pause the video, read the question, and I'll start solving it now. So we'll name this plus and minus, and that's our reference diagram. So So at 3 seconds, you were at 8.4 cm. At 6.1 seconds, you were at negative 4.1 centimeters. So how do you solve for this? So V average is equal to delta x over t. That's the formula that we're going to use because we're solving for average velocity and we're given the time and the uh, distance. So using this formula, we can do 8.4, which is our initial velocity. So it doesn't entirely matter whether you're using your initial or your final first for when you're dealing with delta. However, it is important that if you do your initial for x, you start with the initial for time as well. So 8.4 minus 4.2. This divided by 3 minus 6.1. And you'll get minus 4.06 cm per second. So that's how you solve this problem. For the next problem, and this is question 18 out of the textbook, if you are following along with the textbook, take a minute to read it again and I'll solve it. So we know that it takes 1.38 seconds to get from rest to 9 meters per second. So let's just say that rest is 0 and this is 9.00 meters per second, and let's just make this positive and negative. And then this distance is 1.38 seconds. So how we can solve it is acceleration is equal to delta v over t, which is equal to 9 minus 0 over 1.38 seconds, which is equal to 6.52 meters per second squared. Let's make that a bit cleaner. Okay. Now for part B, it's asking for the same value in kilometers per hour. So this is just simple dimensional analysis that I taught you in the math review video. So 6.52 meters per second squared is we need to multiply this by 1 kilometer over 1,000 meters. Multiply this by 3,600 seconds, 3,600 squared times seconds squared over hour squared, in which you cancel this and this out, and then you get your final answer, which rounds to 84,500 kilometers per hour squared. Again, take a minute to pause the video and to read the question, and then I'll solve it. So in order to solve this, you need to identify your start position, which at 0, your v initial is equal to 28 meters per second. And then your final is 88. So our reference is that this side is plus and this side is minus in the x-axis. And then you know that at the end, your velocity is 0 meters per second. So what you can do is v squared is equal to v naught squared plus 2a delta x. And we can just plug in our values. So v squared is 0 because that's your final velocity, which is equal to v naught squared, which is 28 squared, plus 2 times a times delta x, which in this case is 88 minus 0, which is just 88. And we're solving for acceleration, by the way. So using this, we get that minus 784, minus 784 is equal to 176a. So a is equal to minus 4.45 meters per second squared. And again, take a minute to pause the video and try solving this question yourself. So for this question, so this is where the stone is being dropped from, and it's going all the way to the bottom. So let's name this our 0 position, and this is our y position. So up here, so let's just make a reference, a plus and minus. So the way that we're going to approach this problem is that actually, I'll do something interesting. I'll make the bottom plus and the top minus. And you'll understand the reason after I try it out. So then that would make this our y. So, oops. So that would make this our y. And then this our 0 value. So if we treat the bottom as positive, this all will just fall together. So delta y is equal to v naught y t plus 1/2 a t squared. And delta y in this case will be y minus 0. In this case, y minus 0, which is equal to v naught y, which initially it's 0. So 0 times t plus 1/2 9.81 t squared, because there's gravity acting. And this is why I labeled the bottom as positive, because in here gravity is the only thing acting on this system. So if we can negate that negative sign, it'll just make the solving process that much easier for us. So with that being said, we can just plug in our value of 3.55 seconds. So y is equal to 1/2 9.81 times 3.55 squared. And you get 61.8 meters, approximately 61.8 meters. So whenever you think that you can change the reference to make it easier for yourself, try it out, and hopefully that'll make things easier for you. This obviously will not work in all scenarios, but in this one it does. So you just have to see after doing a lot of problems and repetition. In the next video, I will be doing level 2 problems, and after that, level 3. And then after that, we will be having a quiz, so make sure you study up for that. See you guys.